Dear children, so welcome to the session. The lesson we discussed, that is acid, bases and salt. So in last class we discussed about the indicators, how we can identify the acid and bases with the help of indicators, and what happens when the acid is treated with metals, and what happens when acid is treated with metal carbonates or metal bicarbonates. So what happens, children? When acid is treated with metal, it will form salt plus hydrogen gas is liberated. And when we take the metal carbonates, example sodium carbonate. In sodium carbonate is treated with acid, that is HCl. So what does it forms? It forms salt plus water plus carbon dioxide, that is CO2. So these are all the topics we discussed in the previous session. Now let me continue with that. First, let's take 2 ml of dilute sodium hydroxide solution in a test tube. So we have to take 2 ml of dilute sodium hydroxide solution, and we have to add phenolphthalein solution in that. So what is the color of the solution? Actually phenolphthalein is a colorless indicator. So when we add phenolphthalein in the base, it will be converted to pink color. The pink color is formed. And when dilute HCl solution is added to above solution drop by drop, is there any color change for the reaction mixture? So first we have to add sodium hydroxide solution with phenolphthalein. The pink color is obtained now. So on that we have to add hydrochloric acid drop by drop. We have to observe whether the color change is there or not. So when we add hydrochloric acid drop by drop, means the color of the pink, it will disappear. Finally, the colorless solution will be obtained. So when we add phenolphthalein in acid, means it's form colorless solution. When we add phenolphthalein in the base, it forms pink color, so that we can easily identify whether it's acid or base. So if dilute hydrochloric acid is added to the solution, then the color of the solution fades. The color, it will be decreases. The intensity, it will be decreases. It will become fade. If we keep on adding HCl, if we add HCl drop by drop, the solution become colorless. It's become the colorless solution. And you can see here, to take 2 ml of dilute sodium hydroxide solution in test tube, and we have to add 2 drops of phenolphthalein solution is added to it. Why did the color of phenolphthalein change after the addition of an acid? What is the reason? Why the pink color is changed to colorless solution? What is the reason? Why the color change is took place? So after when we add acid, because the HCl being a strong acid, HCl is a strong acid, it will neutralize NaOH. It will neutralize the sodium hydroxide. So that's why the color change will be there. Does the pink color of phenolphthalein reappear? So when we add sodium hydroxide in the phenolphthalein, the pink color is obtained. After when we add HCl drop by drop, it will be changed to colorless. So after, does the pink color of the phenolphthalein reappear? So which solution is added means the phenolphthalein will be reappear. Yes, base, sodium hydroxide. So when we add few drops of sodium hydroxide solution, it will become pink color. The phenolphthalein will be reappears. If few drops of NaOH is added again to the same solution, the solution become pink. The solution become basic. It's become basic and the pink color of the phenolphthalein reappears. So when we add sodium hydroxide in that solution means the solution is changed to basic and the pink color is reappear. So this is the phenolphthalein indicators. So these phenolphthalein indicators is used to identify whether the solution is acidic or basic. Next, neutralization reaction. So what is meant by neutralization reaction? So neutralization reaction means acid reacts with the base. It will produce salt and water. That is known as neutralization reaction. So acid plus base, it will form salt plus water. That is known as neutralization reaction. So in that, when we add, example for that is acid, hydrochloric acid plus base, that is sodium hydroxide, it will form the salt. What salt it will be formed? Yes, sodium chloride, NaCl, and water is obtained. So this is known as neutralization reaction. And next activity is there. A student drop few pieces of marble in a dilute HCl. HCl means hydrochloric acid contained in a test tube. The evolved gas was passed through lime water. The student is added a few marbles. So marble means what? Calcium carbonate. So calcium carbonate is added in the dilute HCl. The evolved gases it will be obtained when it is passed through lime water. So lime water means calcium hydroxide, that is CaOH twice. So the question is, what change would you observe in the lime water? So what change it will be observed? So what is the formula for lime water? Calcium hydroxide. So when calcium hydroxide is treated with carbon dioxide, what is the product is formed? Yes, calcium carbonate. It will forms a milky lime water is obtained. So lime water turns milky. It will turns to milky. That is, it will forms the calcium carbonate. Write balanced chemical equation for the above change. So what is the change here it's obtained? The lime water turns to milky. So what is the formula for lime water? What is the chemical name of lime water? Calcium hydroxide. So calcium hydroxide is treated with carbon dioxide. What is the formula for carbon dioxide? CO2. What does it forms? It forms calcium carbonate. So what is the formula for calcium carbonate? CaCO3 plus water is obtained. So this is the equation is obtained when the lime water is treated with carbon dioxide. It will form calcium carbonate and water. And next is take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. So what is the color of the solution? What happens to the copper oxide? So what is the color of copper oxide, children? It's a black color. So when we add hydrochloric acid, what is the formula for hydrochloric acid? HCl. So when we add hydrochloric acid and we have to slowly stirring when we add the hydrochloric acid. So what is the change of color? What is the color of the solution? So what is the product is obtained, children, first? So copper oxide is treated with hydrochloric acid. What is the product is obtained? Yes, copper chloride, CuCl2. What happens to copper oxide? The copper oxide is changed to copper chloride. So the color of the solution becomes blue-green. So the copper oxide color is black. When we add dilute hydrochloric acid, the color of the solution is changed to blue-green and the copper oxide dissolves. The copper oxide is dissolved. And the blue-green color of the solution. So the blue-green color of the solution is due to the formation of copper 2 chloride. It will form the copper 2 chloride in this reaction. Next is reaction between metal oxide and an acid. So what happens when metal oxide is treated with acid? So metal oxide, you can take copper oxide. So copper oxide is a metal oxide. So copper is metal. So metal oxide is nothing but the metal is treated with oxygen, it will form metal oxide. When you take the copper, when we oxidize the copper, what does it form? It forms copper oxide. That is known as metal oxides. So when copper oxide is treated with acid, for example, you can take hydrochloric acid. What is the formula for hydrochloric acid? HCl. What does it form? It forms salt plus water. So when copper oxide is treated with acid, that is hydrochloric acid, it forms copper chloride plus water. And reaction between copper oxide and dilute hydrochloric acid. This is the reaction. This is the example for metal oxide and acid. So here the metal oxide is copper oxide and the acid here is hydrochloric acid. So what is the reaction? It will form copper chloride plus water. The formula for copper oxide is CuO and the formula for hydrochloric acid is HCl. It forms copper chloride and water. Okay children, see you on next session.